Hi, everyone. Good morning, good afternoon, good evening. I'm Dan Sharp, and welcome to Security Risks with Low-Code, No-Code Application Development. Over the past few months, I've noticed that there's an increase of usage around low-code and no-code application development environments. And today, I wanted to highlight the security risks associated with standard configurations in these platforms and to provide suggestions on what can be done to recognize and reduce those risks. So a little bit of background on me. I spent the last little over 25 years in IT and software development, with the last 15 of those being in various security roles, from testing an endpoint security solution to security engineer, architect, and currently I'm an application security consultant, which is a relatively general title. So my particular area of focus in the AppSec consulting world is around secure SDLC assessments and hardening plans. And within the software development lifecycle, I'm more focused on the left side, or on the blue team, with particular interest on policy standards and compliance within the governance realm. In design, I tend to focus on threat modeling and security requirements. Within implementation, I look at secure build and deploy processes, software dependencies, which is getting a lot of press lately for software composition analysis, and particularly software bill of materials, or SBOM. And on the verification side, I work on static analysis and dynamic analysis tools. So for today's agenda, I just wanted to go over what is low-code, no-code, give you a little bit of background on what it is, how it's being used, some security risks that we're seeing that are now recognized and published, how to reduce or mitigate those risks through secure software development lifecycle practices, and provide some immediate actions that can be taken if you recognize that you may have risks, or if you're planning on implementing low-code, no-code platform in the near future. So what is low-code, no-code development, or the platforms? So based on my 25 years in software development, there have been a lot of methodologies over the years. I think waterfall is probably the most famous and been around the longest, with the 5 phases, starting from requirements, going through the deployment. Over the last, I'd say, 15 to 20 years, agile development has really taken the spotlight, focusing more around the flexibility. It almost encourages change so that you can implement those changes quickly. It really focuses on the collaboration and customer feedback. In reality, I've only been on 2 teams that have really focused on, one being Extreme Program and the other being Scrum, that were truly true agile development practices. Most of the projects I've been on, they call themselves agile-ish because they do a little bit of a hybrid of agile and waterfall. Now, some of the more popular agile programs or development methodologies, the RAD, or the rapid application development, this one really focuses on that, as the name states, some more of the rapid application development and delivery. And in true agile style, it has the iterative development. There's a scaled agile framework, or SAFe, that's actually gained a lot of traction lately. This is based on lean, which is focusing on delivering quickly and reducing waste, and always improving that cycle time. Now, low-code, no-code platforms are not a methodology, but it does seem to imply the best qualities in the current methodologies. So they tout themselves as being able to build applications faster and more efficiently, lower the development cost, and streamline collaboration and increase productivity. And they mainly focus on doing this by saying that they can take coders and non-coders, and instead of having them siloed, they actually both can contribute to the development and the deployment of software. Now, I will say that security has become integrated in a lot of software development life cycles. That really has, in my experience, only been within the last 10 to 15 years that companies are really adopting and integrating security within the SDLC. And honestly, some companies are still working to build security in rather than trying to bolt it on at the end or create a separate security team who they deem responsible for the security risks of the applications that have been developed. So the focus that I had when learning about low code, no code platforms is, does low code, no code mean low to no security? So if we look at some of the traditional software development roles and why software is created, so normally you have software is either developed or updated to solve a current problem, to create new functionality, or to simplify or improve a workflow for a process. And here, what I'm saying when I say a user or a requester, Agile oftentimes uses the term user, but this could really be anyone. This could be an executive, someone in HR, anyone that's requesting an internal or external application. And typically you have on your development team a variation of these roles. If not a specific individual for each role, sometimes people will take a combination of the roles between the BA, the product owner, architect, developer, and a QA tester. There are certainly other roles, DBAs, UX designers, but usually the core team of any application that I've been on includes the BAs through the QA testers. The goal is that an application is then developed and deployed to a production environment for use, and you have an operations team that then monitors that application in the production environment. What low-code, no-code platforms are promoting is that they can remove the other roles with the promise of moving applications to production faster, with the user taking advantage of the low-code, no-code platform to build and deploy apps. So what does that look like? Within these low-code, no-code platforms, the application developer or the citizen developer, as they're usually called, has access to applications or Canvas apps within the low-code, no-code platform. These platforms also have data connectors, which are pre-built connectors that can connect to a lot of different data sources, databases, cloud environments, emails or inboxes, calendars, Excel files, web-based data, really anything within the network that contains data. There are now connectors that can be used to access that data. Then the application is deployed onto the platform or into the production environment, and that now has access to the data and performs actions based on how the user has set up and configured the application, which is then released to the users who will access the application to eventually access the data. Now, I do want to stress that just because you're not coding does not mean that you're not developing. So the low-code, no-code platforms make it sound as though you can remove multiple roles to save money and move apps to production faster. But you're actually now putting more responsibility on the citizen developer in order to maintain security of the application, the data, and the assets in your environment. So if we kind of look through what some of those responsibilities are, that citizen developer is now responsible for understanding the scope of the application, the flows that need to be put into place, potentially understanding some of the user interface and the user experience so that the user understands how to use the app and accesses the data or updates the data correctly. And that citizen developer needs to understand the acceptance criteria around what needs to be put into place for that application. Typically, your product owner is the data owner and understands the data classification of the application that's accessing the data. You're now putting that in the hands of the citizen developer. The application risk profiles are maintained by the product owner, and they are also responsible for system retirement, replacement, and decommissioning. Architects typically understand those existing system configuration and architectures so that if you are using a data connector, you understand what the implications are for using a specific protocol or the connection to the data. Architects normally also focus on system integrations. So if there's any specific service-oriented or microservices that are used by applications, they kind of understand how those fit together and talk to each other. And they're also typically focused on the architecture security requirements of applications that are moving to production. Developers normally look at the secure requirements that are associated with the application, looking at the input validation and secure handling of data in transit and at rest. Your testers are looking at the functional and the security testing of the application, performance testing, and they are typically monitoring the defect tracking and the fix resolution. They're normally the ones that are opening some of those defects, but they're also monitoring from a regression testing standpoint any defects that come in from users. And then on the operations side, we normally have the system monitoring and the security monitoring and data exfiltration that may occur with the application. So now the responsibilities are transitioned to the citizen developer or potentially the low-code, no-code platform administrator, but this is a lot of responsibility to put onto a single person who is typically a business user and is focused on solving a business problem and not necessarily looking at the security of an application. So the message here is that we really need to still follow a secure software development lifecycle and, more importantly, a secure SDLC. So if we look at what are some of the like a security implication here is that if we take a look at a citizen developer, say Frank in finance, who creates an app to show employees their annual bonuses. So for ease of use and deployment, Frank used his own credentials embedded in the app. So that means that all actions use his permissions. And Frank has full create, read, update, and delete permissions, which now means that any user of the app also has Frank's full CRUD permissions, since his credentials are used for all authentication and authorization. Now, if you're familiar with anything in security, we typically look at the core security principles, which are the CIA triad, which is the confidentiality, integrity, and availability. Now, within AppSec, we also tack on AAA, which is the authentication, authorization, and accountability. And within AppSec, we typically look for any violation of the CIA AAA to determine threats or risks to any assets. So here we can see that because the permissions allow to create, the user to create any new element of data, this impacts the integrity. They can also read any information that Frank has access to. So they are now capable of reading another employee's bonus. This violates confidentiality. They can also update any records that they see, which impacts the integrity, and they can delete any information, which impacts the availability. And because Frank's account is actually used for all of these actions, it directly impacts the authentication, authorization, and accountability. Accountability being logging, because all actions will now appear as though Frank created or performed those actions. And this example actually is not conjecture. What we've seen is that OWASP has come out with a low-code, no-code top 10. So OWASP being the Open Worldwide Application Security Project, they're very famous in the AppSec realm for providing a lot of free information, toolkits, and frameworks to be used for securing applications. They've come out, their most famous is probably the Web Application Security Risk Top 10. It's been around for years. They've also come out with a Top 10 mobile API, and now they have the low-code, no-code Top 10. So the first one on the list here, number one, is account impersonation, which is exactly the scenario that we're seeing when Frank used his credentials. And to dive into that a little bit further, you can see that this it does state that a lot of these no-code, low-code applications can embed the citizen developer's account information, which is then used by any of the application users. So if you're not familiar with looking at the risk rating within the OWASP top 10, the range here is for a low, which is a 1, and a high is a 3. So you can see that 3 being the very highest, this is the highest risk possible for prevalence, exploitability, and technical impact. So kind of going back to the top 10, how do you actually then protect these low-code, no-code apps from the known published top 10? Well, there's actually another OWASP framework tool called SAM, which is the Software Assurance Maturity Model. And here I highlight development in all caps because we do want to stress that no code does not mean no development. Looking at the SAM 2.0, so they're on version 2.0, which has 5 business functions, which you can see up at the top, that run from governance through operations. And each one of those business functions has 3 security practices. So there's a total of 15 security practices within the SAM model. And this is actually used to determine maturity in security practices, but it also has prescriptive information on how to improve security throughout your SDLC. So even if you don't have an assessment performed to know where you fall on the 0 to 3 scale in SAM, you can still use it to identify specific areas where you know you may want to improve security. Now, the model itself actually breaks down even further. Each security practice has 2 streams underneath it. So this creates a total of 30 streams within the SAM model. Now, this is obviously a very busy table, but it highlights the multiple areas of security focus within the SDLC. So how can we use this to help protect against the security risk in the known low-code, no-code top 10? If we go back and look at that number 1 on the list, the account impersonation, if we look at specific areas within the SAM model, the security requirements stream, this defines security requirements to follow during the development process to include authentication and authorization for applications. In control verification, this defines practices of testing of those security controls and the security requirements that were defined in the design phase. And then within the operations side, data protection, there are recommendations on data protections and requirements. So kind of quickly looking through the rest of the top 10, number 2 on the list is authorization misuse. So these platforms may abuse the OAuth authorization flows by storing user refresh tokens and reusing them to reduce the time to deliver. But this lets citizen developers set up connections quickly without thinking about secrets or permissions, but it embeds tokens which may not expire for months or years. So again, if we look at the SAM model, on the architecture design side, this has recommendations for security principle checklists, which include the least privilege principle. So by following that, this will protect against the authorization misuse. And within the secrets management, properly handling and storing of secrets, which would include the refresh rate of tokens and creating a more secure SDLC. So number 3, data leakage and unexpected consequences. So a lot of these applications legitimately access data from underlying services, but can also serve as a conduit to back-end systems for actions that were not anticipated or approved. So this can include data leakage beyond the application or the security boundary. And a lot of these applications, they may sync between multiple systems, and that can trigger unexpected consequences by coupling an operation with one system with a change in another. So to protect against this, within the threat modeling side, you want to understand the data locations, system dependencies, and data flows between systems to identify potential threats. And then again, we see on the data protection side, there are recommendations around automated monitoring to detect attempted or actual violations of the data protection policy. So for authentication and secure communication failures, so some applications typically connect to business critical data through connections which often result in insecure communication. So these connections may offer a variety of security configurations, communications protocols, and authentication flows, but sometimes the business user does not set up the connections properly, and that deviates from best practices and the data security policies. So in the SAM model, we see that within policy and standards, there are secure connection standards, which would include encryption standards and authentication flows. Again, the threat modeling would help you understand the data flows and the connections being used along with their configuration, and the incident detection would monitor environments and platforms for unusual or expected activity. So number 5, security misconfigurations. These can result in anonymous access to sensitive data or operations and unprotected public endpoints and secrets. So many configurations are set on the application level rather than the tenant level, meaning these are set by the business user rather than the platform administrator. So within architecture validation, we can see that reviewing the key components, interfaces, and integrations for those security configurations is covered. Within the misuse and abuse testing, this defines creating and executing abuse test cases, which would include randomization and fuzzing to confirm that those secure configurations are set properly. And again, on the data protection side, this has controls for protecting and preserving data through its lifetime. So injection handling failures, applications ingest data in multiple ways, including direct input or retrieving content from various services. And this data can contain malicious payloads that may introduce risk to the application. Injection flaws are nothing new. This has been on the standard OWASP top 10 for years, and we can see it still on the new low-code, no-code top 10 coming in at number 6. So one of the recommendations from the SAM model within the scalable baseline is to perform automated security tests for input testing to protect against those injection-based attacks. Vulnerable and untrusted components. So a lot of these low-code, no-code applications rely heavily on ready-made components, either off the marketplace, off the web, or custom connectors that are built either by internal developers or external developers that they're using within the platform. And these components are often unmanaged, lack visibility, and expose applications to supply chain risks. So within the SAM model, this directly relates to software dependencies. So knowing the components that an application uses, removing any unused dependencies that are currently in your production environment, and having a defined dependency risk process is all part of the software dependencies stream. Under patching and updating, this becomes very important. So monitoring the components for those vulnerabilities and the related patches, and following an established process for updating components. So this, under the patching and updating, will help define who would be responsible for managing the patching. If the citizen developer is using a component, would they be the one to monitor and perform any upgrades? Or would it be on the application administrator from a configuration and hardening perspective so that they're performing updates from the platform? Or is it a combination of both? In this case, it just depends on your environment. I would recommend looking at both areas and having both the administrator and the citizen developer look at the recommendation from the environment management. Data and secret handling failures. So low-code, no-code applications can store data as part of their code or configuration or on managed databases offered by the platform. Application creators can then decide how to store data, and the administrators often lack visibility into those managed databases. So sensitive data may be stored unencrypted and moved between geolocations without considering regulatory requirements. So within the SAM recommendations, under the data protection, ensuring that data is handled, stored, and monitored in accordance with the data protection policy. Again, we see secret management, proper use, handling, and storage of those secrets used by the application would be defined within the secrets management stream. And then compliance management. So this becomes very critical if you need to consider any compliance requirements. So if you're storing any personally identifiable information, any PII, if you are storing or are in the healthcare industry, if you have HIPAA requirements, storing PHI, if you're in financial and need to store PCI, or if you are within different geographies, within like if in Europe, if you are bound by GDPR compliance requirements, this becomes very important that you understand the type of data and where the data is located. So number 9, asset management failures. So applications are easy to create and have a relatively low maintenance cost. So this makes them prone to abandonment while remaining active, and that increases the attack surface. Internal applications we're seeing can gain popularity rapidly without addressing business continuity concerns. And as the application owner, if employees move within the company or leave the organization, some of these popular business applications may end up without a data owner. So to combat this, having an application risk profile will help classify those applications according to their business risk. It'll document the application owners and it will define the SLAs for business continuity plans according to the risk levels that have been defined. And system decommissioning. This creates a workflow for removing, retiring, or replacing unused or unsupported application using a defined end-of-life process. And then the last one on the top 10, security logging and monitoring failures. So applications often lack a comprehensive audit trail. They can produce none or insufficient logs or overshare access to sensitive logs. Applications can oftentimes rely on vendors to generate the logs and monitor the data. And in many cases, these logs are either insufficient or not being collected at all, which can hinder security investigations should something arise in your environment. So within the SAM model, the incident detection, this is defining how logs are analyzed for security incidents, monitoring those logs for data that may indicate that an incident is occurring, and have a documented process for the incident detection. Now, if we overlay all of the top 10 areas onto the SAM model, we can see that we've covered 12 of the 15 security practices. We may not have covered all of the streams, but we can see that there are 12 of the 15 that are covered. Now, of the 3 that are not covered, I would say that these are just as important. If we look at the strategy and metrics side, really creating a strategic plan for your application security and understanding your corporate risk appetite or your enterprise risk appetite and using that to define risk tolerances will create the security guardrails for all of the other security practices within the SAM model. Within the education and guidance, provide training and awareness to all of your citizen developers on policies, standards, compliance obligations, and the best security practices within the low-code, no-code environments and platforms that you're using. And then the last one, the defect management. This actually becomes very important, understanding how the defects will be collected and reported on. Do those end users report directly to the citizen developer? And how are those being managed? Is it in a standard defect tracking system? Are they receiving emails? And how is that information collected so you can view the defects across all of the application in your environments? So do you see trends? If you're not collecting these defects in a single repository, it's very difficult to see if applications within these low-code, no-code platforms are experiencing the same security flaws if those defects are going straight to the citizen developers. So this slide is obviously overwhelming, and trying to implement security in each one of these practices can be even more so. When we perform assessments and we create hardening plans, we use this framework and build recommendations for 10 to 12 security practices, and we lay that out over a 2 to 3 year period. So trying to implement all of these changes to protect a low-code, no-code environment it's not trivial. It is something that needs to be done, but it's not a quick fix. But it does show that secure SDLC will help mitigate the risk for not only custom development, but also in low-code, no-code environments. So because this is so overwhelming, if you do have low-code, no-code apps in your environment now, and you're worried about the risk, what are the top 3 things that you can do right now to help protect and secure your environments? So the 3 areas that we would recommend are 1, the application risk profiling. This will help you build an application risk profile questionnaire based on the SAM model and the environment and any specific compliance regulations that you need to make sure that you are protecting. Now, building out the profile, it does not need to be complex. This can be relatively basic, a list of like 10 to 12 questions, and you can expand on that over time as additional risks are identified within your environment. So I would start with just make sure you understand who the creator and the owner of the app is. Get a brief description of what the app is designed to do and the purpose of the app. Understand who the target audience is. Who are the users? Who will have access to this? Are they internal users on the intranet? Are they external users on the internet? What type of authorization and authentication methods will be used for the application so that those users can access the data? And what type of input validation and encoding is being performed by the apps? What type of data is being managed or handled by the app? Are there any compliance considerations? Again, the geographic considerations, are you deployed in different regions? And where are the storage locations and how does that apply to the retention policies? Some of these low-code, no-code platforms actually create data in other environments and in their cloud. So if you have retention policies or if you're performing backups of the data in other areas, you need to understand where that data is being stored and make sure that it's adhering to the retention policy. What are the data connectors that are being used and how are they adhering to the encryption standard that you have in place? And are there any external dependencies? And what are the log settings and configurations? Where are those logs going? How are they being monitored? Is it up to the platform? Do you have an operations team that can monitor those logs? These are all things that you can identify by creating these application risk profiles. And when you are creating these profiles, if you're talking to the citizen developer and you get a lot of I don't know responses or blank stares, that's fine. It's just an indication that additional investigation is required so that you can identify those in the profile and make sure that these apps are secure. So second on the list is use that application risk profile information to help build a threat model. Now within the threat model, here we can see, we can just use an example, take the layout that we had before when we were showing the application that Frank had created to display annual bonuses reports to the employees. So here, if we take the information collected from that application risk profile, we now know the target audience, we can identify the authentication that will be used by those users and the application. We'll want to understand what is the authorization of those users, what create, read, update, and delete permissions should they have, and on which data elements should they have those permissions. Understanding where you are performing input validation, should the user have the ability to create, update, the information and pass in those parameters. Look at the compliance considerations of the data, the geographic considerations, again, the data storage locations that would map to those retention policies, and understand which data connectors are being used on that threat model. Look at the encryption standards to make sure that it's adhering to your policies. Identify any external dependencies, and then look at the log settings and the configuration of that application. So this is actually a pretty good start for identifying specific elements within the threat model for the application. But you can actually take this a step further and apply a threat modeling methodology such as STRIDE for each data flow. And then for each one of those flows, determine if there's a threat from the threat category, which then maps to the associated CIA AAA security principle. And again, to start with, this can be very simple and basic. It just gets you off the ground to understand what those threats are. Then as the third element, or the third step for immediate action, use those risk application profiles and threat models to provide education and guidance to the citizen developers. In this case, you want to explain to them any compensating controls and mitigation techniques that you put into place in the environment that help protect the application and data, and help them understand any security risk associated with the no-code, low-code environments and the applications, the connectors, the data elements that they're using or have put into place within their the applications. Use this to provide security training based on those low-code, no-code platforms. Again, make sure they understand how to use the data connectors securely, having them understand any approved authentication and authorization methods, and approved data repository and backup solutions that need to be put into place based on the policies and procedures within your environment. This is meant to create an open communication with the security team and those citizen developers, and it is not meant to be accusatory or argumentative. It definitely is meant to be an open discussion, and one that brings security to light. And it actually is designed to create a culture where security is everyone's responsibility, not just one team's or one group's responsibility. So now these are the top 3 areas that I'm recommending if you already have low-code, no-code apps in place and don't have a strong software development lifecycle with security embedded in it. But if you don't have or are not using low-code, no-code platforms yet, you may soon, because there is a lot of expected growth around these low-code, no-code platforms. So this was an article that I actually saw posted on LinkedIn by a recruiter friend of mine. She was posting it from the stance of, based on the increase in these low-code environments, it may mean that developers are not, they may not have as many job opportunities. I read the article and saw it as, wow, this is really going to increase the low-code platforms. And in fact, within the SD Times article, they reference another Gartner article that expects the growth in 2023 to be up to 20%. And in fact, it will continue to grow through 2026. Now, not surprisingly, because of the rise in popularity, there are dozens of low-code, no-code providers. This is in no particular order and is certainly not a recommendation for any one of these vendors. It's just simply an example of the number of vendors currently out there. And this is, again, from another Gartner review site. The link is here if you want to go out and just take a look at the different platforms that are out there and read some of the reviews on them. So key takeaways from today, there is, again, a large growth of low-code, no-code platforms and their popularity. So if you do not have this in your environment yet, I would expect to see it soon. Again, another key takeaway is that I want to stress that just because there is no code, it does not mean that there is no development. There is certainly development in your environment and within these platforms when you release applications to production. Hopefully you understand and can manage risks for any development, whether that be internal custom development by your developers or using a low-code platform, and implementing security within those software development lifecycle practices. Immediate actions you can take: application risk profiles, use those to help develop threat models, use those too to help provide education and guidance for the citizen developers, and really build that relationship with those citizen developers. So if you have any questions, please definitely feel free to reach out to us. My team and I are always happy to discuss secure SDLC practices. And I would like to thank you for attending today. I hope everyone stays safe and definitely secure out there in the physical and digital world.